Hi everyone. So in this lecture we will be talking about the some questions based on the unbiasedness concept and mean square error based on these two concepts. Yeah. So let's start from the question. The question is let x1, x2, x3 be the ordered statistics from the from the uniform population having PDF. क्या होता है यूनिफॉर्म का PDF? यहाँ अगर रेंज हम लेंगे 0 to थीटा, सो PDF क्या होगा? हैविंग PDF f of x, this will be equal to 1 by theta, if x is between 0 to theta. Then show that for x1 is an unbiased estimator of theta. So in this question we have to check that this 4x1, that is first order statistics, that's the smallest order statistic, is an unbiased estimator of theta. So if I talk about the solution, so this is very simple question in terms of transformation. If we talk about the transformation of this order statistics that comes from the uniform population. So simply, if x follows uniform 0 comma theta, right? So its CDF, that is nothing but x by theta, will follow uniform 0 comma 1, and if this case happens, then x by theta will follow beta a comma b. Now let's decide this a comma b. If we have to calculate x first order statistics divided by theta, then it will follow beta. In place of a we have this first order statistics, and in place of b we have basically this n is 3, right? This is simply n minus r plus 1. What is r? In place of this b we can write this, and in place of this we can write r. That is, r is 1, and this is 3 minus 1 plus 1. Minus 1 plus 1 gets cancelled out, so we will be left with only n. N is my 3, right? So if I calculate xn divided by theta, this will be nothing but in place of r we have n, comma, in place of b we have n minus n plus 1. This and this will cancel out, this becomes 1, n comma 1, right? So but in this question we have to find the expected value of x1 only. So this will be nothing but now see, if I talk about this beta a comma b, so expected value of x in case of this beta a comma b will be a plus b. Now we have to calculate expected value of x1 divided by theta is equal to what's a is 1 divided by 3 plus 1 is 4. So expected value of x1 is equal to theta upon 4. It means that 4x1 is unbiased estimator of theta. It's very simple and easy question, and you can simply use another method, that is method number 2, which says that if you have the PDF of some distribution, that's f of x, then if you need to find the PDF of order statistics, let's suppose x1, then you can simply transform this x1 into the f of x into the x1. How? See, x follows uniform 0 comma theta. What will be the CDF of this x? That is nothing but x by theta, where x is between 0 to theta. Now from the order statistics, order statistics, can you write f of x1 is nothing but 1 minus f of xx raised power n. So you have to remember this formula from the order statistics. What is the CDF of first order statistics? That is simply 1 minus the CDF of our existing PDF. That is 1 minus x by theta raised power n. And to find PDF from CDF, we simply differentiate CDF to get PDF, and if we integrate PDF, we will get CDF. Simply क्या करना है आपको? अगर आपको CDF to PDF जाना है तो आप CDF को डिफरेंशिएट करो, अगर आपको PDF to CDF जाना है तो PDF को डिफरेंशिएट करो, मतलब प्रोबेबिलिटी x is less or equal to x in case of continuous. so ये होगा माइनस इंफिनिटी टू x f of x dx. तो आपको क्या मिलेगा? f of x x. एंड अगर आपको यहां से यहां जाना है, मतलब CDF to PDF, तो आपको क्या करना है? d by dx f of x x आपको मिलेगा f of x. ये दो फार्मूला आपको याद रखनी. Now see, we have the CDF of first order statistics, that is d by dx of 1 minus f of xx raised power n. तो इसमें हम क्या करेंगे? इसमें क्या होगा? पावर डाउन 1 minus f of xx raised power n, और इसका डिफरेंशिएशन ऑफ 1 is 0, तो इसका क्या होगा? 1 by theta f of x, that is 1 by theta. क्योंकि इसको डिफरेंशिएट करेंगे तो 1 by theta मिलेगा. क्योंकि x by theta d by dx of x by theta, x का 1, ये मिलेगा 1 by theta. ठीक है, तो यहाँ पे आएगा 1 by theta. तो ये होगा n by theta 1 minus x by theta raised power, यहाँ पे होगा n minus 1, होगा n minus 1. सो मिल गया हमें f of x1. तो यहाँ से आप एक्सपेक्टेड वैल्यू ऑफ x1 निकाल सकते हो, इंटीग्रेशन x f of x1 dx1. तो यहाँ से आपको एक्सपेक्टेड वैल्यू मिलेगा जो होगा बराबर 4x1 is equal to theta. तो ये आपको मिलेगा यहाँ से. आप कैलकुलेट, ये आपका होमवर्क है, आपको कैलकुलेट करना है. नाउ लेट्स मूव इनटू द सेकंड क्वेश्चन. दो तरीके आपको मैंने कहा, एक तो बीटा वाला और एक सिंपल PDF CDF कैसे हम करते हैं. ठीक है, सो क्वेश्चन नंबर 2 देख लो क्या होगा. क्वेश्चन नंबर 2 इज बेसिकली ऑन द कांसेप्ट दैट्स मीन स्क्वायर एरर. मैं आपको बता दूं, एक मिनट, क्वेश्चन को पहले मैं देख लूं. या उससे पहले एक और क्वेश्चन कर लेते हैं. मीन स्क्वायर एरर से पहले एक और क्वेश्चन कर लेते हैं. द क्वेश्चन सेज दैट question is very simple. It says that let x1 x2 up to xn be a random sample from Bernoulli 1 comma theta. Show that t n minus t divided by n minus 1 is an unbiased estimator of theta 1 minus theta where t is equal to summation xi. ठीक है, आपको ये दिखाना है, मतलब इस पे एक्सपेक्टेड वैल्यू लेनी है और वो किसके बराबर आना चाहिए? इसके बराबर. ये आपको दिखाना है. सो क्या करेंगे हम? सिंपली अगर अगर x फॉलो कर रहा है बर्नौली 1 गामा थीटा, तो समेशन xi विच इज t, सो ये किसको फॉलो करेगा? बाइनोमियल n गामा थीटा. ठीक है, अब आपको क्या चाहिए? अब आपको चाहिए expected value of t which is nothing but n theta, and variance of t क्या होगा? n theta 1 minus theta, as you know if you remember the distributions. So expected value of t square क्या होगा, वो होगा n theta 1 minus theta plus n square theta square. क्यों? क्योंकि expected value of t square होगा बराबर variance of t plus expected value of t का whole square. Clear है? Is this clear? Yeah. So we have to operate the expected value of t n minus t divided by n minus 1. So ये क्या होगा, 1 upon n minus 1 will be my common term, क्योंकि ये तो कांस्टेंट है ना, तो ये तो बाहर आएगा. एक्सपेक्टेड वैल्यू ऑफ वेरिएबल हम लेंगे, एक्सपेक्टेड वैल्यू ऑफ कांस्टेंट इज कांस्टेंट है. सो ये होगा एक्सपेक्टेड वैल्यू ऑफ एन टी, इसके साथ मल्टीप्लाई करो तो ये एक्सपेक्टेड वैल्यू ऑफ एन टी माइनस एक्सपेक्टेड वैल्यू ऑफ टी स्क्वायर. क्लियर है? सो ये होगा 1 अपॉन n माइनस 1 n, व्हाट्स एक्सपेक्टेड वैल्यू ऑफ t, यहाँ पे हमने देखा है n थीटा. सो ये होगा n थीटा minus what's expected value of this t square, that is n theta minus n theta square plus n square theta square. मतलब अगर हम इसको फिर से लिखेंगे, ये होगा n square theta minus n theta plus n theta square minus n square theta square, n square theta square, यही होगा ना. या सो यहां से अगर हम पहले n को कॉमन निकालो तो ये होगा n थीटा माइनस थीटा प्लस थीटा स्क्वायर माइनस n थीटा स्क्वायर डिवाइड बाई n माइनस 1, ये और ये कैंसिल आउट. अब देखो या तो हम यहां से थीटा को भी कॉमन निकाल सकते हैं, यहां से एक थीटा आएगा, यहां से थीटा आएगा, यहां से थीटा आएगा, यहां से थीटा आएगा. सो ये होगा n थीटा, यहाँ पे बचेगा 1. यस, सो ये बचेगा थीटा n माइनस 1. ठीक है, n माइनस 1 को एक साथ लिखो और माइनस n थीटा प्लस थीटा, क्या हम इसको ऐसे लिख सकते हैं? डिवाइड बाय n माइनस 1. अब यहां से भी आप थीटा कॉमन निकालो, थीटा कॉमन आएगा यहां से, तो अंदर बचेगा 1 माइनस थीटा n माइनस 1. अच्छा हाँ, n माइनस 1 अगर हम यहाँ से थीटा को बाहर निकालेंगे क्या बचा, n माइनस 1. देखो कैसे, थीटा n माइनस 1 और यहाँ से क्या आएगा, n माइनस 1 को कॉमन निकालो, यहाँ पे अंदर बचेगा 1 माइनस थीटा. सो ये और ये कैंसिल आउट, सो ये हो गया बराबर थीटा 1 माइनस थीटा, मतलब एक्सपेक्टेड वैल्यू ऑफ t n माइनस t डिवाइड बाई n माइनस 1 इज इक्वल टू दिस, हेंस प्रूव्ड. सिंपल है, बस कुछ नहीं है, कैलकुलेशन है, बस आपको पता होना चाहिए कि इसको कैसे हम ओपन करते हैं. नाउ एक और क्वेश्चन देखते हैं. एक और क्वेश्चन देखते हैं. तो कंसिस्टेंसी पे है, अनबायस्डनेस पे एक और क्वेश्चन देखते हैं, देन उसके बाद हम एक और क्वेश्चन लेते हैं किस पे, इस पे मीन स्क्वायर एरर पे. हाँ, क्वेश्चन देखो क्या है. क्वेश्चन इज लेट x1 x2 up to x6 is a random sample which is random sample is basically IIT, that's known. Random sample from normal mu comma sigma square. Determine C such that C x1 minus x2 square plus x3 minus x4 square plus x5 minus x6 square is an unbiased estimator of sigma square. So how to solve this type of question? Simply we have to operate the expected value on this. But before that uh, we have to write what's expected value of x1, that is mu, which is equal to expected value of x2, expected value of x3, expected value of x4, expected value of x5, expected value of x6, expected value of x6, x6, expected value of x6. Now what's variance of x1, which is sigma square, which is equal to variance of x2, variance of x3, variance of x4, variance of x5, variance of x6. Why do I write this? Because it's given that it's a random sample, which means that the distribution of x1, x2, x3, x4, x5, x6 is same, as x1 follows normal mu comma sigma square, x2 will also follow normal mu comma sigma square. That's why I wrote this down. So what will be my expected value of x1 square? That is variance of x1 plus expected value of x1 whole square. Clear? So now we have C x1 plus x2 minus x2, sorry, x1 minus x2 plus x3 minus x4 plus x5 minus x6 square, which is equal to sigma square. We have to find the value of this C. Now taking this side, can I write C x1 square plus x2 square minus 2x1 x2 plus x3 square plus x4 square minus 2x3 x4 plus x5 square plus x6 square minus 2x5 x6. So this is equal to C. Now do one thing. Let's write expected value of, this is constant C, expected value of this whole term. Can I write this as, sorry, can I write this as C expected value of x1 square plus expected value of x2 square minus 2, as xi's are IIDs. So can I write this as expected value of xi, expected value of, expected value of x1 multiply expected value of x2 plus expected value of x3 square plus expected value of x4 square minus 2 expected value of x3, expected value of x4 plus expected value of x5 square plus expected value of x6 square minus 2 expected value of x5, expected value of x6. Now see, this is equal to C. What is the value of xi square? That is variance of xi plus mu square, that is sigma square plus mu square plus sigma square plus mu square minus 2 mu square, as expected value of x is mu and this is also mu, so mu into mu is mu square plus sigma square plus mu square plus sigma square plus mu square minus 2 mu square plus sigma square plus mu square plus sigma square plus mu square minus 2 mu square. Sorry. Now see, mu square plus mu square is 2 mu square. This and this will get cancelled out with this. Look at this. This is mu square. So mu square plus mu square minus 2 mu square. Mu square plus mu square is 2 mu square minus 2 mu square, that is equal to 0. this will get cancelled out, this will get cancelled out. So C, this is 1 sigma square, this is 2 sigma square, this is 3 sigma square, this is 4 sigma square, this is 5 sigma square, this is 6 sigma square. 6 sigma square. So this is 6 sigma square. C 6 sigma square is equal to sigma square. Now see, if sigma square is equal to 1, then C is equal to 1 by 6. Now put C is equal to 1 by 6 in this. So this is 1 by 6. 6 sigma square is equal to sigma square. This 6 and this 6 goes. Sigma square is equal to sigma square. Hence, C is equal to 1 by 6. So what's the value of C? That is 1 by 6. Now look at the this important question. Now we are going to talk about an interesting question which is based on the mean square error. That is nothing but, let me write the question. The question is let x1 x2 up to xn be a random sample. यहां से इससे बाहर आपको कोई क्वेश्चन भी नहीं आएगा एग्जाम में. कंसेप्ट तो यही रहेगा. फ्रॉम a normal mu gamma sigma square distribution where both mu and sigma square are known, find the value of b that minimizes the mean square error of TB is equal to b n minus 1 summation xi minus x bar square for estimating sigma square where x bar is equal to 1 upon n summation xi. This question basically tries to or we can say this question is asking about to find the value of this b that minimizes TB, mean square error of TB basically. So here is the concept. First of all, unbiased estimator, then mean square error. That is nothing but variance of let's suppose mean square error of an estimator is equal to variance of that estimator plus biasness of that estimator with whole square. So you need the value of this b after finding the mean square error of this, and here is the word that is minimizes. So whenever you are asked to find the value of b that minimizes, or you find the word minimization or maximization, think about the differentiation. Differentiation of what? We will see that later. So see, s square is nothing but 1 upon n minus 1 summation xi minus x bar square. As you know, this is the formula of s square is this. So n minus 1 s square will be summation xi minus x bar square. Clear? And n minus 1 s square divided by sigma square follows chi square n minus 1. And if we find the expected value of s square, that is nothing but sigma square. How? Because expected value of this is n minus 1, n minus 1 will get cancelled out with this n minus 1. This sigma square will get shifted to right hand side. Expected value of s square is sigma square. And what's variance of this? This is n minus 1 whole square. Variance of s square divided by sigma 4 is equal to 2n minus 1. So this will get cancelled out with this. So variance of s square is equal to 2 sigma 4 divided by n minus 1. Why? See, if x follows chi square, xi follows chi square n, then expected value of xi, this xi is equal to n. Variance of this xi will be 2n. Clear? So if this is chi square n minus 1, then expected value of this will be n minus 1. Then variance of this will be 2n minus 1. So now we have seen that expected value of s square is equal to my sigma square. Clear? And variance of s square is 2 sigma 4 n minus 1. So clearly my TB is equal to bs square. bs square. See, my TB is equal to b. This is my s square. bs square. Now, what is MSc of this TB? That will be nothing but variance of bs square plus biasness of bs square whole square. Sorry. And biasness is nothing but biasness of t is nothing but expected value of t minus theta. As you know, expected value of t is equal to theta plus biasness of t. So biasness of t will be expected value of t minus theta. ठीक है, ये मैंने आपको unbiasedness में करा दिया है. So now variance of constant into variable, that will be constant square variance of variable plus what is biasness of this? This is nothing but expected value of bs square minus bs square minus what is my theta? Theta is my this sigma square. This is my sigma square ka whole square, this whole square. So this is b square. What's variance of s square? That is 2 sigma 4 upon n minus 1 plus b, what's expected value of s square? That is sigma square minus sigma square ka whole square. So this is b 2 sigma 4 upon n minus 1 plus sigma 4 will be my common. This will be b minus 1 whole square. It's simple calculation here. So now let's suppose this is my g of b. Let's suppose this is my g of b function. Now we need to find the value of this b that minimizes MSE of TB. MSE of TB. So now we need to differentiate this. See, if we have the function f of x, we have to check that if there is a local minima or local maxima. So we can simply differentiate this function and put that equal to 0. And if double differentiation of this function is greater than 0 or less than 0, in here, if this is greater than 0, we will get the minimum value. If this is less than 0, we will get the maximum value. So on the basis of these two, we can conclude that if there is minimum or maximum. So see, g of b is equal to this. Now differentiate g of b with respect to b. So g dash of b is nothing but the differentiation of b will be 1. So we will be left with 2 sigma 4 upon n minus 1 plus sigma 4. This is 2b minus 1. Simple differentiation. And we need to put this equal to 0. So 2 sigma 4 upon n minus 1 plus 2b minus 2 sigma square is equal to sigma 4 is equal to 0. क्या होगा ये यहाँ पे sigma 4 is equal to 0. Sorry. So can I write 2 sigma 4 upon n minus 1 plus 2b sigma 4 minus 2 sigma 4 is equal to 0. Once we calculate this from this equation, we will get b is equal to n minus 1 upon n plus 1. You can solve this equation and you will get b is equal to n minus 1 divided by n plus 1. And now calculating, differentiate again, differentiate g dash b, we get, अब हमें g dash b को डिफरेंशिएट करना है, मतलब जो हमें यहां से मिला, ये मिला ना हमें, अब इसको डिफरेंशिएट करना है। तो ये होगा, पहले इसमें तो जीरो आएगा, इसमें तो जीरो आएगा क्योंकि इसमें कोई b नहीं है, इसमें b है। तो देखो हमें डिफरेंशिएट करना है d बाई डी है, d बाई डी बी, d बाई डी बी किसको करना है, इसको करना है ना, सिग्मा फोर 2b माइनस 2, इसको डिफरेंशिएट करना है। ठीक है, तो सिग्मा 4 तो कांस्टेंट है, एंड डिफरेंशिएशन ऑफ कांस्टेंट इज 0। अब अगर हम देखो यहाँ पे क्या होगा, सी ये होगा d बाई डी बी 2b सिग्मा 4 माइनस d बाई डी बी सिग्मा 4 2 सिग्मा 4। ठीक है, तो ये तो पूरा कांस्टेंट है, तो इसकी वैल्यू क्या होगी, 0। ये क्या होगा, ये जो कांस्टेंट है ये बाहर आएगा, 2 सिग्मा 4 d बाई डी बी ऑफ b, d बाई डी ऑफ b। तो ये क्या होगा, सिग्मा 4 एस सिग्मा स्क्वायर इज ऑलवेज ग्रेटर देन 0, सो ये क्या होगा, ग्रेटर देन 0। मतलब जब ये ग्रेटर देन 0 हुआ, मतलब जब ये ग्रेटर देन हुआ, तो हमें क्या मिलेगा, वी विल गेट ए minimum value at b is equal to n minus 1 upon n plus 1, hence proved। so b की वैल्यू कितनी होगी, n minus 1 plus divided by n plus 1, क्योंकि ये वो वैल्यू है जो पूरे फंक्शन को हमें मिनिमम बना देती है। मतलब किस फंक्शन को, MSE of TB को ये मिनिमम वैल्यू बनाती है जब हमारे पास ये होता है, b की वैल्यू ये है और डिवाइड बाय n minus 1 समेशन xi minus x बार स्क्वायर। तो ये तब मिनिमम होगा जब b की वैल्यू ये होगी। ठीक है, सो दिस वाज द क्वेश्चन। नाउ नेक्स्ट लेक्चर में हम देखेंगे कंसिस्टेंसी।